Alright, welcome back to Geometry 12.6 spheres, and we're going to briefly look at 12.8 congruent solids also. Alright, in spheres, when we're looking at surface area is 4 times pi r squared. So 4 times the area of a circle. 4 times pi r squared is the surface area. So if I want to find the surface area, here I have the radius. Pretty simple if you have the radius. 4 pi, put in the 6, r squared, calculate that. There we go. Alright, now a few terms. When a plane intersects a sphere, it can either intersect in a point, that means it just touches the outside of it, or in a circle when it cuts it. A great circle is formed or created when the sphere and the plane intersect through the center of the sphere. The endpoints of the diameter of a great circle are called poles, and hemisphere are 2 congruent halves of a sphere. So to visualize that, this is what that looks like. A great circle, notice that plane goes through the center right here. The poles are the ends where the diameter meets the outside of the sphere. And the hemispheres are the 2 congruent halves. Hemisphere is a half of a sphere. Okay, so if I want to find the surface area of a hemisphere, well, I can find the area of the sphere, 4 pi r squared, and then I also have to find the area of a circle. Okay, so I'm going to have half of the 4 pi r squared gives me the outside, and then plus the area of the circle, which is like the base here. So I know the radius, plug that in for radius, and then plug away, type, and the surface area is 73.9 centimeters squared. Okay, if I'm looking at the volume of a sphere, the volume is derived from the formula for the cylinder, where the cylinder is pi r squared, which is the area of the base, times the height. So the area of the base times the height will inscribe a sphere into a cylinder. So from bottom to top is the same length, okay, and the width, the diameter is the same. So pi r squared times the height. Now if I were to fill this with water or whatever else, I'd find this is 2/3. It holds 2/3 the volume of a cylinder. So I need 2/3 of the volume of a cylinder. 2/3 pi r squared times the height. Well, the height, a sphere doesn't have a height, but from here to the top, this, what corresponds to the height on a cylinder, is 2 times the radius. So the height is 2 times the radius, so we can replace height with 2 times the radius. So here's a formula for the volume of a sphere. Now we can simplify that a little bit. We can do 2 times 2 to get 4/3, and then r times r to get r cubed. So all in all, when we simplify this, we get the formula volume equals 4/3 pi r cubed. Okay, so if I want to find the volume, in this case, they were sneaky and didn't give me the radius. If they gave me the radius, it would just be plug and play. Put that in, type. Here we know the circumference, so first we have to find the radius. If I know the circumference, I know the circumference is pi times the diameter. So here we know 18 pi is the circumference. Divide by pi, I get the diameter is 18. And then to get the radius, that's half of that, so the radius is 9. Plug it in, plug and play, type in your calculator, and the volume is approximately 3053.6 centimeters cubed. Okay, similar solids. Similar solids, they are similar if they have the same shape and the ratios of corresponding linear measures are equal. So we have proportions here between similar solids. So the ratio between the two is equal between the corresponding measures. For congruent solids, they are congruent if their angles are congruent, if the corresponding edges are congruent, and corresponding faces are congruent, and their volumes are equal. And that's about all we have for today.